All right, sweet guys, welcome to our session today. And let me start the session today. There was a question, and I think I sent it on the group. I didn't look at it though, but I sent it on the group hoping I would get answers. I think Google said she tried, but she got stuck. Let's quickly look at that question and see if we can. All right. All right, I have it here. I should have actually transferred it here, but everybody, let's look at this together. So this is what we have. We have something that looks like that. Okay, and we have okay, it's a stick guy, and this guy is in. Okay, this guy is, I'll read the question. I don't know what this is, but we'll draw first and we will understand later. All right, 30 degrees, check. Now, let's listen. The skier, all right, in a diagram below, has just begun from rest. So they told us he started from rest. We're going to interpret together, guys. Descending the 30-degree slope, the coefficient of friction is 0,1. So what do we write? The coefficient of kinetic friction is 0,10. Neglect the effect of air resistance. Number one, define in words the term acceleration as applied to physics. Please, everyone, quickly define it. Write it down. I'm not going to make assumptions. You know it. No. Please define acceleration is 2 marks. You have 2 minutes to recollect and define. And then we mark. Oh, I should have this paper. Hold on. This is Limpopo 2020. Okay, while you are defining, I'm just checking the top now. Limpopo 2020. Maybe I do have 2020 prelims. Do I? Great. This is why I like to collect papers. I promise you, I'm a paper collector. Limpopo 2020. Oh, there we go. There we go. You see my stick guy? Beautiful. Limpopo 2020. There we go. That's the question. I just looked up now on the paper. Beautiful. All right. I'm sure you are all done with the first question. And what is that? The rate of change of velocity. If you forget in an exam, go back to your equations of motion and find this formula. Vf minus Vi equals to A, divide both sides by delta T. What do you have? Vf minus Vi over delta T, which is delta V. Can you see where I got my definition from? The rate of change of velocity. We okay? Everybody 2.2 quickly. Answer 2.2. Answer 2.2. I'm going to add another question to that 2.2. You state that one first in terms of A, acceleration, B, momentum. So I have two definitions that I'm expecting. A, in terms of acceleration. B, in terms of momentum. A in terms of acceleration and B in terms of momentum. Let me put a time frame. Now you have 3 minutes just to write down, think and write. Are we all done? Looks like I gave you too much time. Né? Now we should be done. What is Newton's second law in terms of acceleration? When a net force acts on an object, what happens? The object will accelerate in the direction of the net force. Right? With an acceleration that is what? Directly proportional to the net force and inversely proportional to the mass. What about the second one? What's wrong with it? What's the second one? Just use this one. Net force is the rate of change of momentum. That's the second one. So when they ask you in terms of momentum, that's what it means. That is what it means. All right. Okay, everybody draw a labeled free body diagram. Let's draw a labeled free body diagram. Free body. Thank you for those definitions. Give me a free body. All right, so what do we have? What can you see? There's gravity there. There's force of gravity. What else? There's normal force, which is 90. Please, a lot of learners still draw that normal force wrong. The object is moving down, so there's friction in the opposite direction of what? Motion. So what is that? Kinetic friction. What is this? Normal. And what is this? The force of gravity. Okay. Examiner says calculate the acceleration of the sky. Let's see. Acceleration. Now, usually what do? We redraw that diagram. Let me just draw that diagram here again. But please, we don't work with this diagram. It's going to be very confusing for you. FK, FG, and normal. What do? We draw it into components. Normal there. What do you have here? FG perpendicular, parallel to the surface. And then what do you have here? Friction. So we have friction. We have FG perpendicular, which is mg cos alpha. You write that immediately. FG parallel, which is mg sine alpha. And then we have what? Normal. The examiner says we should do what? Find the acceleration. Let's see. What is the formula for acceleration? We would say F net is equal to ma. And we will look at the forces that are responsible for the motion of the object, which I think it's actually this guys. It's this one, because the object is moving horizontally. I hope we are all in agreement. So what do we know? We choose the direction of motion as positive, which is this. So what are we going to have? FG parallel plus negative friction equals to what? MA. But I see that we don't even have friction though. What do we have? Coefficient of kinetic friction. Let's quickly work with that. Friction will be what? Mu K N. Right? All right. Do we know the frictional force? No. Okay, but this one is also equal to what? Mg cos alpha. That's our normal force. The normal force is equal to Fg perpendicular, which is that. Okay, let's see. Fk, I think this is 0,1. Do we know the mass? No. Okay, let's see. We're not given the mass. Times 9,8 cos what? 30. Do you want to put that in a calculator for me? Let's see. So our answer would be in terms of mass. Okay, looking interesting. Quickly. Child, do you have your calculator here? Okay. Zero comma. So you took 0,1, 9,8 and cos. So 0,849 m. Now that's our friction. Let's take it back in. All right. So what is my FG parallel? Or let's deal with that quickly out here. What is it? Mg sine what? Alpha. Is that fine? Do we know the mass? No. Do we know G? And sine what? 30. What would that give us? 4,9 m. Right? Sine 30 is half. Beautiful. Now, that should be equal to what? MA. Let's throw everything back. What is my FG parallel? 4,9 m minus 0,849 m equals to what? I'm done now. What is 4,9 minus 0,849? 4? 4,051. M equals to what? MA. Can I divide both sides by A? By M rather. What's my answer? 4,05 meters per second what? Squared. We're done. All right. Google, I don't know where you were stuck on this question. But are you here? Is Google here? It was Google who tried. She sent me a message, and it was Gracia that sent me the question, though. All right, but did it make sense? I first was puzzled because there's no M, but I realized, oh, okay, let's just continue. Use the correct principle, continue, and you'd walk through. 1 second, I know you're writing. Calculate the speed of the sky after 6 seconds. Okay, awesome. Now we want the speed of the sky. Speed after 6 seconds. I don't think that should be much of an issue. We're looking for final velocity, right? Let's list the things that we have. That will help us. Initial velocity is 0. Acceleration is 4,05. Time is what? 6 seconds. And we're looking for final velocity. You see, once I do that, I quickly pick out my formula. What formula do you see? I see VF equals to what? VI plus A delta T. What's my VI? 0. What's my A? 4,05. And my time is what? 6. What is the answer? 24,3. 24,3 meters per. I'm sure this one is about 3 marks. Let me just check quickly. Yeah. Formula, substitution, and that. I hope that makes sense. Beautiful question. So you see, I want us to learn the skill of just continue. Interpret well and continue. And let's see where it will lead us. We're good. Awesome, everybody. Can I get your thumbs up, thumbs down? You okay with what I did? Made sense? All right. And most importantly, the skill, right? You start, you interpret correctly, you write down the things. You can see, even while drawing my free body diagram, I was writing down the things, interpreting immediately. Awesome. Okay. Photoelectric effect. I don't know if you guys were able to look at this question. Did you? Can I see something quickly? Wait, how many of you were able to look at this question? Thumbs up, yes. Thumbs down, no. I want to see how we distribute the time. Thumbs up, yes, you looked at it and you did it. Thumbs down, no. All right, many of us were writing, so I see a lot of thumbs down. Okay, great. So let me give you a chance. You have 6 marks here. We have 5 minutes to look at this. Try. It's not good if I just start. Okay, maybe because you need to read. There we go. Just this first 6 marks. All right, let us answer. The diagram below shows a photoelectric cell which is connected to an adjustable EMF. The group of learners used the device to study photoelectric effect. The learners irradiate the cell with blue light of wavelength 490 nanometers. They record the readings on the ammeter as the cell is irradiated with blue light of different grades. Now, I see that is written in italics, so I am also going to underline that. There must be something. Okay. Define photoelectric effect in words. All right, thank you. It's a process, in case you didn't get it right, and you guys have definition sheets, so use it. It's a process whereby what? Electrons are ejected from the surface of a metal when light of suitable frequency, that word must be there, light of suitable frequency shines on it. There are 4 definitions that I need you to practice here. It is photoelectric effect. It is photon. What is photon? A packet of energy. What do you have? Threshold, frequency, the minimum frequency of light required to eject an electron from the surface of a metal. And then what do you have? Work what? Function. Those are the 4 definitions they are going to ask you. And just is the nature of light in this case, which is the particle nature. Light can act as a particle through photoelectric effect. All right. So I believe everyone has that definition right under your wings. For this experiment, write down the independent variable. What are we changing? The changing factor or changing variable. What do you notice? It is different grades of what? Intensity. So, I am changing 10.2.1. I am changing intensity, or you can call it the number of photons. Intensity means the number of photons. 10.2.2. What are we keeping constant with respect to light? Okay, let me see your answers here. You want to type in your answers here quickly for me? Let me see your answers on this one. Simply says the type of light. Remember, we are using what? A blue light of the same wavelength. What do you think here? They said light of the same wavelength. In fact, that gives it out already. I don't know if you see that. But you said the type of light. That's important. The type of light. Because there are so many blue lights. So we can say the type of light. That's important. But what are we keeping constant? The wavelength. Which is also, we can also say frequency. I don't know if that makes sense. All right. So we are using the same type of light, but just changing intensity. What is 10.2.3? Investigative question. I love this question. What is, that's how I like to do mine. What is the relationship between intensity, but what are we measuring? Amount of current. Right, lovely. So what is the relationship between the intensity and the number of electrons ejected? or you can say the amount of current produced. Please put a question mark. If frequency is constant, let's keep. If frequency is constant, I want us to mention all the variables: controlled, independent, and dependent. If frequency is kept what? Constant. If frequency is kept constant, I hope that makes sense to us. All right, so mention the three variables. Very, very important. The independent is what you're changing. The control is what you keep constant. And the dependent is the result. So we want to measure the amount of current produced. And that's why we are using an adjustable EMF. All right? Okay. Can I move? Everybody good? Now let's answer the next. How many questions? 3, 2, 2, 7. 3, 2, 2. Sir, Chris, I just explained what investigative questions are. It is a question, just what is the relationship between, you mentioned the independent, you mentioned the dependent, and you mentioned the constant. That's all. Whether you are doing physics or chemistry, just start with that phrase. What is the relationship between independent and dependent, keeping the control constant? You fill in the gap. Put a question mark. What is the relationship between independent and dependent if the control is kept constant? So yours is to identify the independent, the dependent, and the control. I hope it makes sense. Whether it's physics or chemistry, same story. All right, let's see your calculation here quickly. And you answer 7 marks. 7 minutes. Too long though, but yeah, okay. Shoot everybody. Please start. Read the question and answer. Okay, let's answer. The learner observes that the ammeter reading increases when the intensity of blue light increases. Explain this observation. Look, they will always ask this. Always. The effect of intensity or the effect of frequency. The learner observes ammeter reading increases. When intensity, you're just simply saying increase in intensity. This is how I'll answer it. Increase in intensity. Let me break. I want to squeeze everything here. Increase in intensity means more photons. And then means more photons are incident. More photons will eject. More photons will eject more electrons per unit time. Please, this is important. Current is measured per unit time. So if that's not there, we're going to have a problem. Don't just say more electrons. It is more electrons per unit time because we are measuring current. What did you get for 10.4? What are we looking for? We're looking for kinetic energy. What do we know? E equals to what? Work function plus kinetic energy, right? But we don't have E. But they gave us wavelength. There's a formula there. Hc over what? Wavelength equals to work function plus kinetic energy. Do I know H? 6,63 times 10 to the power negative 34 times. You're saying? Are you saying something there? 3 times 10 to the power 8 over. What is your wavelength? 470 times 10 to the power negative 9 nano equals to, do we have work function? 2,35 times 10 to the power negative 19 plus what? Kinetic energy. What is my answer now? What did you get? Child. Let's see. What's your answer, people? Share your answer with me. 6,63 times 10 to the power negative 34 times 3 times 10 to the power 8 over 470 times 10 to the power negative 9. I'm bringing that whole thing minus 2,35 times 10 to the power negative 19. 1,88. All right, 2 decimal places times 10 to the power negative 19. And the unit is what? Joules. Let me know. Thumbs up, thumbs down. Are we okay? I'm only getting a few. We're good, Sitley? So a mistake? All right. Briefly explain why metals shine when the frequency of the radiation falling on the surface is below the threshold. If it's below the threshold, you know what it means? It means there's no photoelectric effect, right? So let me quickly assist you with that. 10.5. I'll just give you a few notes. Below threshold, below threshold means no electrons are ejected. This is not part of the answer. No electrons are ejected. All right. Electrons gain energy. Let's write as quickly as possible because time is going to go on us. Gain energy when photons are absorbed. When photons are absorbed, they move from ground state. They move from ground to excited state. That's point one. When energy is lost, or let's say when electrons move from excited to ground, what happens? Energy is lost in form of photon, and that is light, which makes the metal to shine. Which makes the metal. This is a very beautiful question. I love it. Application. Which makes the metal to shine. Let's write quickly. Which makes the metal to shine. That is an application there, and they are applying both absorption and emission spectrum. All right, I'm sure by the time you are done here, time might be off on us. But let's expose ourselves to as many questions as we can. And as you're practicing, start sending in what you would like us to answer. Okay. Can I move quickly? All right. You can quickly screenshot, electrodynamics. Guys, we have the second link once this kicks you out, or kicks us out. Let me say us. Okay. Oh, Doppler. Let's get this 14 marks. Let's get this 14 marks. And we are going to give ourselves 12 minutes. All right, 12 minutes. It's going to kick us out definitely. It's definitely kicking us out. Once it kicks us out, just use the second link. We'll log back in immediately. But time continues. All right, guys. Can you hear me? Okay, guys, can you hear me? All right, let's answer the questions quickly. A commuter train passes a passenger platform at a constant speed of 40 meters per second. A train. The train horn is sounded. Okay, so that means the train becomes my what? My source. Always read to confirm that. All right, Vs is 40. All right, we know the frequency of the source. We're given as what? 320 hertz. Take the speed of sound. All right, V is 340. State Doppler effect in words. I'm sure everybody's able to do that, right? The change in frequency observed when there is relative motion between the listener and the source relative to the speed of sound in air. Whichever definition you have on your formula definition page, please make sure you master that. Expect that in any test. All right? Expect that in any test. Calculate the frequency heard. What are we looking for? Frequency heard. Frequency of the listener. As the train does what? Approaches. Approaches means towards. That's a common thing to do, right? So, formula. Plus or minus. Excuse me there. All right. We write the formula the way we usually write it. Copy it from the formula page first. But which sign are we going to use? If it is towards, what do you say? Upward must be positive. All right. So towards tells me plus and minus there. Take note of that. As simple as that. Now I'll change my formula. Plus VL. Which one is stationary, by the way? The listener is stationary, so I normally throw it away. I don't even put it. All right, I just throw it away. Whichever one is stationary, just get rid of it. Over V, we know the bottom should be what? Negative. I think here it is just straight substitution. 340 over. It's approaching. I'm expecting my answer to be higher than 320. Always take note of that. Minus, what is Vs? 40. And what is the frequency of the source? 320. What's your answer? 362, comma. Can somebody please confirm that this answer is wrong or correct? Let me finish before you give me that face, man. All right, it's correct. Okay. Now, calculate the what? Wavelength detected. I'll tell you the common error here. Wavelength detected. So we are looking for wavelength of the listener by a person standing on the platform. Now, where do you get wavelength from? We get wavelength from V equals to what? F times that. Here is the common mistake. Please, this is going to be the frequency of the listener and the wavelength of the listener. This one is the speed of sound. That's where learners make mistake. It's the speed of what? Sound. It's not, you see, it's not the speed of the listener. It's not the speed of the source. It is the speed of sound. Some of us might have made that error. All right, speed of sound. Let me copy the page. So I love what we're looking at, just to make sure we cover all the errors. Speed of sound. Okay, you'll give me those values again. So we said V is F of the listener, that of the listener. What is this? 3. They said take the speed of sound to be what? 340. We're given that. What is the frequency of the listener? 362, comma 67 multiplied by that. So what do? We divide both sides by 362. What is our answer? 0, comma 94. And remember, wavelength is in meters. I hope that's good. So we learned something there quickly, right? Please. Now the next question says, a motorcycle starts from rest. What does that tell us? Initial velocity is 0. And accelerate along a straight line at 2.8. So I'm quickly taking my stock take, doing a stock take there. See what I have. The speed of sound in air is 343. Okay, they've changed everything now. A siren at the starting point remains stationary. The siren, which is going to be my source, right? So Vs is equal to what? 0. Use a suitable calculation to prove that the distance, what are we looking for? Delta x, that the motorcycle has traveled when the driver hears the frequency. Hears, talk about what? The listener of the siren at 90% of the value. Please, interesting. 90%, let's interpret. When the frequency, here's the frequency of the siren, FL, 90% of means times the value of the frequency, the value when the motorcycle is what? Stationary, which is the frequency of the source. Please, let's interpret carefully. 90% off. And by the way, this guy is moving in which direction? Is it towards or away? Come on. A motorcycle starts from rest and accelerate. The speed of sound is 343. A siren at the starting point. The motor car also, they said at the, not a, that means they were both stationary. At the starting, so they were both at the same point. It only means one thing. This guy is moving what? Away. Check again. How do I know it's away? The frequency of the listener is 90% of the original. It has dropped by 10%. So the frequency of the listener is lesser. Okay. What are we looking for? They said what? Prove that the distance is that. Okay, hold on. Let's see quickly. So they brought in motion. Nice. How I'm used, they gave me delta x. I'm looking for delta x, right? Okay, let's check. Vf squared, because I don't have time, right? So I won't use anyone with time. This is the formula that's coming to my head. Do we know the final velocity? What is the final velocity? Stop lying. Velocity. We don't know this. Child. Do we know the initial velocity? Yes. 0 plus 2. Do we know A? Yes. Do you notice we have two unknowns? We have two unknowns. We don't know delta x. Don't use the 209 they gave you. That's what you must get. The question is, how do we calculate the velocity of the... This is going to be the velocity of the listener. I don't know if it makes sense. It's going to be, because we are looking for the final velocity. Oh, they gave us Doppler here. Come, let's work. FL, this guy is moving away. If it is away, what are we going to have? V minus VL over V. Is that fine? And this is what? Fs. Let me know if I'm losing you. Let's quickly check. Thumbs up, thumbs down. You think I've lost you so far? Let's see. Please give me a thumbs down if I've lost you. I see thumbs up. Tina, where have I lost you? Quickly. You want to talk to me very fast? Unmute yourself. Talk to me. Sia, please talk to me quickly. Where have I lost you? I need someone to unmute. Tina, Sia, Because I need to know where I've lost you. Please assist me in finding you.
Sir?
Yes.
So why did you decide to use the Doppler effect?
Because I was given frequency. There's no way I'm going to get... The guy is moving away. All right, check. Let's go back. The guy is moving away. We don't know this. We know the frequency here is this. But we know that the frequency here is 0.9, or let me say 90% Fs, which is 0.9 Fs. But we do not know the velocity of the listener at this point. I don't know if it makes sense. The source is stationary, but the listener is moving. And we said, if we use equations of motion, Vf squared equals to Vi squared plus 2a, this is all about the listener. So final velocity of the listener, we don't know. 0 squared plus 2,81. We also don't know delta x. So we have two unknowns. The question is, where are we going to get the velocity of the listener from? Sia, I don't know if that question is answered. Tina has a question. Why are we using FL? Because we're given. Go. Then that's why I'm interpreting the question and reading and underlining. Use a suitable calculation to prove that the distance, delta x, that the motorcycle has traveled when the driver hears means listens, the frequency, can you see that's frequency of the listener? All right, here's the frequency of the siren at 90% of means times the value it has when the motorcycle is stationary. Let me quickly give you a point here. When the motorcycle is stationary, all right, stationary, when both are stationary, that is VL equals to VS, or whether they are both moving, know that Fs is also the same thing as FL. Tina, I don't know if I was able to break that down for you. So guys, the thing is, where am I going to get FL from? From Doppler. Because I have frequencies. Check now. FL equals to V minus VL over V plus VS, which I don't really put, but let's check. What is FL? It is 90%, which is 0.9. What is my V? They said 343, right? Do I know VL? Do you see I don't know? 343 plus 0. Can you see what's remaining? From there, I'm going to get my VL. How do I get that? Divide both sides by Fs. Make sense? Now, what do? Cross multiply. 0.9 multiplied by 343 equals to 343 minus VL. Come, give me an answer. If I bring that VL over, what will it be? Do the maths for me quickly. Do the maths. Give me an answer. $34.3. Are we confirming? Final answer. Are we confirming that, everybody? If you are not getting it, let's see. Let's help. Just move things over. Move the other one to that side, becomes a negative. The VL becomes positive. Oh, so now, check. I know this. 34,3 squared would be equal to, what is 2 times that? That would be 4, that is 265 delta x, right? What do we do? Divide both sides. Quickly do that for me. 343 squared divided by 5,62. Let's check if we are going to get it correct. We must get 209. If we don't get 209, then we're wrong. Don't forget the squared. Tell me if you are getting 209, those of you at home. Kimwen, what are you getting? Are you sure? Did you? That's what we got, child. Okay, what's your answer? Because you are looking. What's your answer? Shouldn't take you so long, Sikli, man. What's your answer? Child, I can't. Why is it taking you so long? It's 34,3 squared, 34,3. Are you just if you are doing university maths? Divided by 55,62. We are done there. Simply 209,34. And what were we asked to show? Beautiful. Perfect answer. 209,34. Did that make sense, everybody? Did the process make sense to you? Process makes sense to you? Let me quickly talk about graphs of this Doppler. Can I look at graphs quickly? All right. There are two graphs, two different things I want to quickly look at here, guys. Number one, let's look at constant speed. If the speed is constant, your graph is going to be a straight line. Towards will be higher than away. So this is going to be FL, and away will always be less. Please take note of that. And we can have right in the middle the frequency of the source. They can give you that. Towards will be higher, but this will be at constant what? Speed. At constant speed. Take note of this. But what happens when the object is accelerating or decelerating? What happens when the object is accelerating? I just want to show you the skill that I need you to use. All right? Accelerating away from the source. Okay, please check this. What is this? Away. I don't want you to cram it. Just quickly think mathematics. I want to teach you a skill. Away. So it means my source is stationary. Check the formula. FL equals to V. Away tells us it's negative up there, right? So minus what? VL over V, because my source is stationary. Because this thing can change. So then I don't want you to cram it. I want you to look at the skill. If it is away, it is minus up. All right. Away from the source, it means my Vs is stationary. So I have that formula. Now, if it is accelerating, what are we saying? We are saying VL is increasing. Please, I want you to listen to this carefully. VL is increasing. You just take a number. If you don't know how to think maths, use a number. Start by saying 340, look, minus 30 over 340. Give it any number. Let's make it nice. Let's make it 340 so that it can cancel out quickly. That will quickly cancel out. What is your answer? 3 what? 10. Now, let's increase VL. 340 minus 40 over 340. This one is still what? Constant. I want you to be skillful. What's your answer? What do you notice happening to frequency of the listener? Decreasing. So what will my graph look like? We are going to start from 340. But then as the speed increases, it goes to 310 and goes to 300. Check that. I don't know if that skill makes sense. Just throw in figures, compare the values, you will see whether it's increasing or decreasing. Please let me know if what I just explained makes sense to you. Let me try something. Let's try something. I want to see. I want you to sketch the graph. Can I give you one quickly? 5 minutes. Sketch the graph if... Are you ready? Okay. Please sketch the graph. Source moving or source accelerating. Please check. It is the source that is moving now. Accelerating towards a stationary listener. Quickly, you have 5 minutes. Interpret. I want you to draw the graph. Source moving towards a stationary listener. Velocity of the source and frequency of the listener. Five minutes. Take your time, quickly interpret. It's 2 marks, but because I'm just explaining this to you, giving you time. Are we done, guys? Are we done? Are you okay with what you did? Okay, let's save the 30 seconds. Could be very useful. What do we know? Moving towards. All right, so I know FL would be equal to what? V. Which one is stationary? The listener. So this would be what? Stationary, so I can remove that. Is that fine with you? Use your numbers again. You are looking for FL. So FL is what? 340 over 340 minus, you could use anything. Maybe you could use 10 first to see what's going on. And you have what? 340 or whatever you want to use. 340, I don't know. But you'll get an answer. Okay? Whatever answer you get. As long as you use the formula as well. Then you come here again and say, F. You don't have to use my own values. Over 340, the speed is increasing. Okay, but I can tell you what's going to happen. If I subtract 10, then I'm going to get an answer there. All right, 330 at the bottom. And then 300 at the bottom on that side. As the bottom becomes smaller, FL is going to increase. So FL is going to increase. My graph is going to look that way. What did you get? Is your graph like that? Why not? Huh? No, the source is accelerating. You didn't read. The source is the one moving now. So my graph should be like that. Let me know if you got it. Thumbs up, thumbs down. Who gave me a thumbs down just now? I saw a thumbs down. Let me see. Chris, what is the challenge? Chris, what is the challenge? Just use numbers. You use plus instead of minus. No, it's towards. Towards, up is positive, down is negative. Know the correct signs. Please know the correct sign. If it is towards, if it is away. All right. That is done. Okay, quickly. 11 marks. I'll give you 10 minutes. And then we're marking the remaining 10. Did we manage to finish? Did we manage? Still busy? Let me see. If you're still busy, give me a thumbs up. Okay, guys, I'll give you 5 minutes. I'm going to extend the session just about 15 minutes. All right? Because I want everyone to at least try. I'm going to extend the session for about 5 minutes. Okay, I think we can quickly mark this. Let's see. Probably we don't even need an extension, but let's see. Maybe just we extend for 15. I said 15, right? Just to look at Newton's laws. All right, let me see if I can use 5 minutes to quickly answer this question. A ball is falling freely when it's falling freely. That gives me an idea of a free fall there, right? Good. When its downward speed reaches 9,2, it explodes into 2 equal parts. Part 1 goes straight up to a height of 13,7, and part B continues. Define momentum. I'm sure you can do all of that. Calculate the initial velocity of part 1 just after explosion. Now, we were told after explosion, it actually goes back up and reaches a velocity of what? It reaches a height of 13. it means the final velocity there is what? 0. We do not know its initial. It's a free fall. Okay? So can we use our free fall equation? Vf squared equals to Vi squared plus 2a delta y. Final velocity is that. I do not know that. What is my A? Oh, let's choose downward as positive. Okay, if my downward is positive, mean upward will be negative. But acceleration is always downward. So 9,8. What is my delta y? Negative 13,7. Why? Object is going what? Up. We chose downward as positive. If you do this with your calculator, what are we going to have there? We are going to have 2 times 9,8. I'm moving it over already to the other side. 2 times 9,8 times 13,7. If I move it over, it's become positive already, right? So I then look for the square root of that answer, and that gives me 16,39. They said velocity. It has to be upwards. Remember, when I look for the square root, it's actually plus or minus. So the correct one will be what? Negative. It is plus or minus 16,39. And the correct one would be the negative. I hope you understand why it's negative. Because it's going where? Up. We chose downward as positive. If this kicks us out, I sent you a new link. We just quickly use that for 15 minutes. State the principle of conservation of linear momentum. All right, I'm passing that. In an isolated system, the total linear momentum is conserved. 99.9% of the time, you have to use it in the next calculation. It always works. Now, what are we looking for? We are looking for the velocity of part 2 after explosion. Oh, wait. These things were together before. So, M1 plus M2, initial what? Velocity. Now, they are separate. M1 Vf1 plus M2 Vf2. Remember, I'm still choosing downward as positive. All right. Since they are of two equal parts, what's my initial? 9,2. Now, M, what is my final velocity after explosion of object 1? Negative 16,39. Why? It goes up at that point of explosion. Plus M, and I don't know Vf2. What is this? 9,2 multiplied by 2m. Okay, let me do this so that everybody sees where my 2m comes from. Negative 16,39m. What is 18,4 m plus 16, what? 39m equals to mvf2. What will that give us? 18,4 plus 16,39. Then we divide by m. That's 30 something. Okay, it's 79. 34,79. 32. 79. Because this is 16,39. Sitley, leave me alone. Vf2 meters per second. Are we okay, guys? Are we okay with my explanation? Thumbs up, thumbs down. It didn't even take me up to 5 minutes. What are you checking? Is it correct? Do you agree? Comma? Yeah, 34. Well, now you gave me 2 and I believed you. I said 34. Leave me alone. You said 32. All right, guys, it's that child. Now you must trust your instincts, Chris. Trust your instinct. Let's see. I think we have Newton's laws. Let's just try this Newton's laws quickly. Let's work together. A physics learner pushes a 34 kilogram crate up the plane with a horizontal force of magnitude F, parallel. Okay, look at the force. Very lovely. Oh, I'm glad we're actually looking at this. As shown in the diagram. The coefficient of kinetic friction is 0.25. Suggests a reason why the coefficient is dimensionless, has no unit. What's your answer? It is a ratio of forces. Ratios don't have units. Ratios don't have unit. The crate moves up at constant what? Velocity. Keep that in mind. What do you know about that? Acceleration is 0. State in words Newton's first law. I know most of you know second law. Please go and learn all the laws. Huh? First law? An object will remain at rest or continue in uniform motion unless acted upon by a non-zero resultant force. All right, guys, draw a lib. I need you to draw this. Quickly, everybody. Draw this. Draw this. Please draw the free body. If it kicks us out, please log in again. We'll finish this and then we'll just... And on the group, I sent you lots of links. And there we go, just when I was talking. Kicked everybody out. Phsc. All right, I'm sure you are done with your free body. Let's see what it would look like. Let's see what the free body would look like. What do we know? There's gravity on the object. Is that fine with us? There's friction. How is the object moving? Object is moving up, so friction should be acting where? Down. Down the plane. There is normal force. And then there's applied force. In which direction? There. What's wrong? Did you get it correct? Don't tell me sort of. It's either yes or no. Huh? Please, we must draw up all forces out of the dot. All forces must be drawn out of the dot.
The same thing, but then in my head, that thing was facing. But then look, it would be correct if it was.
But look at your friction.
No, my thingy was like, take this image and.
Why would you do that?
My head.
Your head. and you didn't draw an arrow on your force applied. Guys, did it make sense though? Talk to me. Are you okay with the diagram? It's quite lovely. So don't cram anything. Just understand the principle. You know, physics is very dynamic. Soyama, oh, okay, you gave me a thumbs up. All right, I thought you gave me a thumbs down. Guys, don't cram anything. Physics is very dynamic. Just go with the flow. All right. Now, it says, use an appropriate calculation. Show that the kinetic frictional force acting on the crate is that. Okay. Now, we have quite a big problem here. Let's try to change this diagram. Remember, we always want to work with vertical and horizontal. So what are we going to do? Let's try to resolve quickly, as fast as we can, before we even start calculation. All right, we have normal there. What do we have here? FG perpendicular. We have friction. Here you can even draw your surface. You know, you can use a pen so you're not confused. All right? You can draw a surface when you are resolving. What do I need? Parallel. FG parallel must be parallel to the surface. Can you see that? That's why I need to draw that surface. This is friction. This is FG parallel, which is mg sine alpha. What is this? FG perpendicular, which is mg cos alpha. The question is, where is my force applied? How is it going to be resolved? Let me start by doing this. Here is my force applied, but I don't want it to look that way. Can we resolve this? Can we resolve this? It must be vertical and horizontal. Vertical means it must come this way. All right, very tricky, very tricky. All right, and horizontal. Okay, let's go to the diagram and try to resolve it. Now, if I were to draw a line this way, let's use the diagram because that would be a lot easier. If I were to draw a parallel line that way, what do you notice? You would notice that this angle will be 25. I don't know if that makes sense. Corresponding what? Angles. Okay. So, I have that. Corresponding angle. So that gives me 25. But I want to draw it in such a way that I have a vertical and a horizontal. This is quite tricky. Okay, let's draw our normal force. Our normal force is that way. Do we agree? Lovely. What does that give us? 90 degrees. Make sense? So if I want to then resolve this in terms of I want to find a vertical, I want to find this, and I want to find that. No, sorry. I want to find that way because I want all my forces to go up there. So I need a component. And I want to find this one. What are we going to do? Let's work together. What are we going to, let's use a bit of maths now. What are we going to do in terms of the angle? So this is my Fy, and this would be my what? If we can get Fy, then we're good. Normally when we resolve, what would we be looking for? Would be looking for, check this. If I do this, everybody watch this. I'm going to try to complete that triangle there. Are we okay? So, I can definitely get my Fx there. What will my Fx be? Using that triangle. I'm going to call this F Okay, that is Fx. No, it must be parallel to the plane. F parallel there, right? Okay, it's going to be a big mess, but I wanted to follow through. F parallel. And that is my, so this is actually not my Fx. I'm lying to you guys. Because x, we are saying x, when we say x, it must be parallel to the plane. All right, this is F what? X, parallel to the plane. Okay, let's see, let's play around. It's quite tricky. But already we agree at that 25, right? And we agree at that 90. All right, let's see. My head is not medicine right now. Fy? No, it can't act downwards. It shouldn't act downwards. Okay, just give me a moment there, all right? If that is 25, this is 25. I'm just trying to quickly look for something here. Trying to look for something here quickly. Just give me 1 second to think, guys. I just want to look at something here. I'll get back to you just now. All right. Okay, so this is my 90 degrees. We agree? All right, I'm just trying to do a construction to make us understand. I don't want to do things from my head. Now, do you notice I have a 90 degrees here? A right angle triangle. Check this line. Why am I saying 90? It's parallel to that line, my normal force. Make sense, everybody? Good. So this becomes my hypotenuse. All right, and this angle, this becomes my opposite. So what is sine 25 degrees? Fy over f. Let me know if that makes sense and we agree. Let me know if we agree on that point. If we are all on the same page, we agree. I need to hear from you guys quickly. Yes, Chris?
Hello, sir.
Hi.
So with this kind of question, the way we used to answer it, isn't it like how we do Newton's second law? Wouldn't the same method work?
It's the,
Like
we are still doing the same, but you must notice this force is not parallel to the surface.
Oh.
Yeah. So that's why I said don't cram things. We're still doing Newton's second law. Check. Don't cram things. Let's work it out the way the examiner has given us. Look at this, everybody, quickly. I'm actually glad we're looking at something very different today. Beautiful. Let me expand this. So we have this. All right? Please make sure you follow. And you are free to argue. We can argue things. That's why we are science learners. We argue things. I have force there. Okay, we're given the force. I think it was like that, right? It doesn't even matter whether it's touching there or not. But that's what we're given. Okay? Watch my interpretation if you agree. So this is the original question. 25 degrees. We're good. We said we normally work with vertical and horizontal what? Forces. Normal is vertical. So we're going to use our normal force as our cue to draw a vertical force. Do we agree there? Okay. So this is normal. It means our vertical force must be in the direction of the normal force. So that is what? Fy. Make sense? And I'm just thinking, just for everyone to see, if I were to construct a line parallel to that normal force here, what is this angle? 90. what is this angle going to be? 90. Make sense? There are other ways, but I want to make sure I carry you along. And what do you notice here? That gives me a right angle what? Triangle. It means this is also Fy. Equal forces. Same length, same direction. And if this angle is 25, do you agree that this angle is 25? Check. Alternate angles again. Can you see that? Make sense? Alternate. So I have a right angle triangle here. Looking at this angle, this becomes what? Opposite. This becomes my hypotenuse. So what is sine 25? Opposite over what? Hypotenuse. So what is Fy? F sine 25 degrees. Thumbs up, thumbs down quickly. Talk to me. Do you agree with my interpretation? Is it making sense? Emmanuel, quickly talk to me. You have 30 seconds. Where are you lost? Hi, Emmanuel.
So I'm lost as to how, like, do you see your FY, so
Yep.
I don't understand how it's like the bottom FY equal to the top FY.
Because it's a triangle, remember. Okay, let me show you something. Let me help you. Let me go another way. Let me go another way. If I draw that, whoa, this, do you agree? Keep your mic on. Would you agree that that is 90?
Oh, yes.
Okay. And what will this be? 75 degrees.
Yes.
We okay? We agree there, right?
Yes, sir.
And if that is 75, would you agree with me that that is 25 degrees?
Yes, sir.
Good. What is this? Opposite.
Yes.
And against my 90, what do you have? Hypotenuse. So what is your opposite over hypotenuse? Fy over F. Make sense? Yep.
It's 65, not 75.
Oh, 65. Okay. Doesn't even matter anyway.
I'm just saying, sir.
Yeah, thank you.
Okay.
No? It's okay. But are we okay with the process, thought process?
Yes, thank you, sir.
All right. So the next thing with what is our fx? Remember, when I say fx, it must be horizontal to the surface, which is like this. But, guys, I want you to see this. Let me make this a bit thicker. Oh, this is such a beautiful question. Right? But are you aware that if I push it down, it's actually that? Which is now my adjacent to this triangle. That is my, look, this is it here. This is it here. If I were to, it's not, okay, I'm not, my lines are not parallel. But this is the same as that. But acting in the upward what? Direction. So what is this? Fx. What is cos? Cos 25. Oh, this is so beautiful. I love it. Adjacent over hypotenuse. So what is Fx? F cos. All right, with this, we are done with the question. We can now find. So if I were to draw a new free body diagram, look at what it looks like. My normal, let me make this thinner. We have normal, FG, perpendicular. Where is friction acting? Downwards. Where is FG parallel acting? Downwards. What do we have here? F parallel, force applied parallel, and force applied perpendicular. Can you see we have successfully converted all our forces to vertical and horizontal? Fx, Fy, normal, friction, Fg perpendicular, Fg parallel. Please let me know if we are all on the same page now. This is sine alpha, which is 25. Mg cos alpha. Are we all on the same page? F cos 25 and F sine 25. Examiner is really testing your math here. All right, thumbs up, thumbs down. Let's see. Thumbs up, thumbs down. We all good? I think from here we can deal with the question. But this is so beautiful. I just love this examiner. I don't know the examiner. Just love the examiner already. All right. Use an appropriate calculation. Let's see. We'll see if we are right or wrong here. Calculate the frictional force. What do we know? Frictional force is always... frictional force will be what? Mu K N. Always look at your diagram to get your N. How many forces are pointing up? 2. All right. This will test. Yeah, this will be a test whether we are correct or not. 2. And how many forces are pointing here? 1. Normal is not always mg. All right. What do you notice? Normal plus Fy is equal to what? Fg perpendicular. Please, the forces pointing up must be equal to the forces pointing down. Normal plus Fy equals to what? Fg. Let's check. What is our Fy? F sine 25, I think. And this one is what? Mg cos alpha. Let's write the whole thing out. I'll be finishing now once we get this correct. What is the mass? Do we know the mass? 34. All right, 34. 9,8 cos what? 25. All right. Anybody wants to give me that value? 34, 9,8 cos 25. Sorry? 301,98 minus F sine 25. I've taken my... All right. Now, what is frictional force? It is mu Kn. We're about to reach the moment of truth. What is my coefficient? Do we have it? 0.25. Okay. Moment of truth. Into bracket. 301,95 minus F sine. All right. Please multiply this in and multiply that in. Quickly. What is 301,95 times 0.25? 454 minus... Sorry? 495 minus... What is 0.25 sine 25 degrees? Quickly. 0.25 sine 25. 10. And there's F there. Let's see what we are proving. 45,495. There we go. So that should make you believe in my components. Did that make sense? Did that make sense? Ooh, such a beautiful question. Such a beautiful... I love it. I love it. I just love it. Did it make sense, everybody? And you can believe that we got it right by getting the answer they want us to prove. I noticed in this paper there's so many proof that this examiner is showing off. All right, guys. Make sense? Please, it should be uploaded just immediately. You can rewatch it to still have a full day. Okay, but I love it. I just want to close quickly here because I've taken extra time. Hence or otherwise calculate the magnitude of force F. All right, they said constant what? Velocity. Beautiful. We are now looking for F. We know that F net must be equal to what? MA. Which forces are we using? Which ones are horizontal? Can you see the forces? How is the object moving? Up, right? So we take this as. So what is it going to be? F cos 25 minus FK minus FG parallel. I hope everybody's okay. F cos 25 minus FK minus. Okay, I'm going against my laws. I usually like to do it like this. Equals to what? MA. Let's substitute. F cos 25 minus. If I bring this friction in, I'm multiplying everything by negative, right? So what would it give me? Please watch the maths now. 495 plus. I hope you understand that. Where I'm getting my plus from. Because it's minus open brackets. Okay? Plus or minus mg sine. What is m? 34. What is g? 9,8. Sine what? Is that fine with you? mg sine. And this should be equal to 34 times 0. I think we have our answer already. Check this. Let's simplify this. Like terms. 106F would be equal to 0 plus. I don't know if you have a calculator there and you're already typing it for me. I have moved that over. It became what? Positive. I'm also moving this over. Quickly, get me an answer on the right hand side. And I'm factorizing this. (34) times 9,8 sine 25, close the bracket, plus 75,495. Confirm. All right. Now, what do we do? That answer divided by, can you see the way I factorize that, right? So what do I have? Cos 25 plus 0,106. Are we good are we okay with the maths? Factorize and divide to make life easy. 213,68 newtons. Let me know if we're good. Let me know if we're good. The process. Guys, please, don't cram physics. The principle that you have will always work. That's how physics is. Don't cram it. Use the principles. All right. I'll be sending this to you. I'll just resend all the links of the classes we've been having for a build-up towards your physics, so you can then rewatch and rewatch. Plus, please let's help each other on the group. Send questions on the group. When someone sends, let's walk through together. Are we good? Okay. Have a lovely evening, everybody. I took a bit of your time, but it was worth it. I'll share this link just shortly. Okay. Free body diagram. Yeah.
Instead of it like pushing, it was pulled. So the force was.
If it was pulled, you mean going this direction now?
No. As in, like they do the same force, but here. And instead of saying it was pushed, they said it was pulled. Okay, sorry. They said it was pulled.
Yeah,
Would we?
it's going to be the same thing.
Okay.
Let's check. It's pulled, so it's going up. But if it was pulled, then, all right. Let's see. I think someone was trying to ask a question here. Okay, no one. All right, guys.
Nita. Nita.
Okay, Google.
So, I have a question. It's like of a previous question. Like before this.
Which one is that?
I think it's. Let me see. Yeah, this one.
Yeah.
Why did you put negative 16,39 for the second equation?
Direction. When this thing split up, what were we told? This guy is moving up.
Oh.
And we chose down as positive. So if it's going up, it has to be a negative velocity.
Which means if you chose up as positive, for the first time you were supposed to get negative 16,39.
Yes, that's why I said it's plus or minus.
Oh, okay.
Hence I put this here upwards. Negative 16,39. All right. Okay, guys, goodbye.